Hello, hello. Good morning, good evening, wherever you are. My name is Mark Borstein. I'm the CTO of Trumbull Security. And joining me, I actually don't know who this is. I've not seen him in a while.
It's been a while.
Sorry, who are you again?
Yeah, I don't know. I forgot yourself too, America. I don't remember why I'm here. Yeah, between vacation, work, some other things.
How
I think
dare
it's been
you have
3
a day
weeks.
job?
Yeah, that pays the bills, right?
Yeah.
Writing books doesn't really pay us, but it's good to still do. So, hi everybody. I'm Scott Strowich. I'm a principal engineer at a global tier one bank, and just general geek, right? So.
Yeah, so this is a fun chapter. I like this chapter. So this week we are doing the labs from chapter 12, Node Security with Gatekeeper. Now, I know you guys use OPA. Are you using Gatekeeper or are you just using like raw OPA?
We're doing some conversion over to it, and
Gatekeeper.
there were some, there were some reasons for the delay, just because, if you have existing OPA policies, it's not as easy as just saying, bring this in,
Yeah,
right?
exactly.
So that was the delay, and honestly, Gatekeeper has some great features, obviously, but was there a real reason for us to go through all the work to migrate everything at the time? There is now, so we're doing that. But of course, this leads into under conversations, which I wasn't here last week. But do you think about Kyverno? Do you think about Cell?
Right.
Do you think about? And let's face it, in the cloud world, if you're looking at everything coming out or what's new, man, you'll never implement anything.
Well,
right?
that's true.
You'll just talk about what you should implement, and you just can't do that. You should always evaluate new stuff, absolutely. But so we're doing that, Mark.
Sweet. So, last week we did Gatekeeper and OPA, and we looked at how to write policies, right? This chapter is a lot more specific in that we're going to talk about node security and how we lock down our nodes. What's interesting about this chapter is, over the 3 editions, it's gone through quite a bit of evolution because it started off where we were dealing with pod security policies. And right after the 2nd edition got published, I think it was right after. It was either right after or right before the 2nd edition got published. PSPs got deprecated. So if you don't, if you're not familiar with PSPs, because we're talking 2020, right? When PSPs got removed, 2020, 2021, something like that. So it's been a few years, but that was the original attempt to protect your nodes. And when I say protect your nodes, something that's important to understand is, well, doesn't RBAC do that? No. RBAC is designed to protect your API server, right? It protects your API, but it doesn't really do a lot for the nodes. And that's because, a lot of people don't appreciate the disconnect between API level security in Kubernetes and node or machine level security. They're 2 completely different mechanisms, right? Like, whether or not you can create a pod, that's the API's problem. Once that pod gets created, what that container looks like is a completely different sublayer of security, and the 2 don't, they don't cross, right? I thought it was interesting. You had brought this up. I think we were talking about trying to lock down things like kube control exec and file monitoring and what that looks. Or I think we were actually talking about if you have a long-term exec process and your token expires, like what happens? Well, it just keeps going because.
Yep. Hey, Mark, I'm not hearing you. You're on mute. No, you're on mute now. According to the screen, you got a little.
Hey, can you hear me? Something weird is going on because I keep getting it.
What's going on with my computer? And I'm like, wait a minute, it's your mute.
Yeah, something weird is going on where it keeps muting my mic.
Wow.
But anyway,
It's your computer saying stop talking.
yeah, exactly. Mark, shut up and run a lab. So it's a different layer of security, right?
Mm-hmm.
And so we start off this chapter, and where we start is we start talking about what is node security, and the first place we really dive into, and I think this is really important because it gets lost, is the difference between a VM and between a VM and a container, right? Because like a VM, and this is assuming you're using Docker or some other kind of more typical container engine. If you're talking about micro VMs, like what's the one that Google uses?
Oh, yeah, well, that's not. I wouldn't even know. I would rate Kata containers as being a better
Kata,
example from Intel.
right?
Yeah, you got gvisor, right? That's Google's,
gvisor,
but
that's the one I was thinking of. Amazon has, I think, Firecracker, I think it's called.
yeah, yep.
There are a few of them. They're really they're interacted with as if they are containers, but really they're micro VMs, and so there's hardware isolation, right? There's some hard multi-tenancy there, whereas most containers are not. They're just processes,
Mhm.
right?
Yeah, I
And
think a lot of them
so
call that just enough VM. It's like a kernel, essentially,
yeah,
to a level. But yeah.
exactly. And so why that becomes important is like if you go to your if you go to your VM, so like I'm gonna share here. So like I'm running on my I'm actually gonna you know what, I'm gonna go, do I have one? Actually might not have one. I actually blew up my lab cluster. Well, I didn't accidentally blow up my lab cluster. My NAS died in a power outage. Um, so most of my VMs are down. But anyway, we have an example where if you're running Kubernetes on a VM and you log into that VM and you run Docker, or not even Docker PS, just ps-a as root, you're going to see all of your container processes listed out, right? And that's because they're just processes. By the way, if you're out there in Cyberland, please say hello, ask us questions. We love to hang out. So so we start off the chapter. We're talking about containers and how to securely design containers. Because you know you can think of any container as a remote code execution, right? I put a bunch of stuff in a container. I tell an API to run it, and if that container gets compromised, oops. That's a whole other set of conversations around supply chain security. But we wanted to start with the container itself, and so where we start getting into labs. So I'm on page 345. And we start talking about container breakout. So, Scott, you remember KubeCon in San Diego? We went to that secure Kubernetes lab. It was like the last thing we went to.
Yeah, the capture the flag one, right? That we were
Yeah.
doing. Yeah.
I think it still exists. Let me double check here. No, I don't. Yeah, fine. Allow. Yes, it still does. Whether or not it works, I don't know, but
Well,
um, the link is still good. So, Secure Kubernetes, great lab if you want to learn about how scary security in Kubernetes can be. And one of the things that came up was a way to break out of a container. So when we say a container breakout, your container might think it's isolated. But again, it's just a process, right? A container in the Linux world, a container is a set of different technologies, right? It's C groups, it's
Namespaces.
UID isolation, namespaces,
Well, Linux namespaces. Sorry, we got to.
Linux namespaces.
Yeah, let's
Exactly.
make sure
Not the same thing as Kubernetes namespaces. But the idea is the same, where it's like, okay, well, we're making the container think it's running on its own little slice of the world, but reality it's not. And if it thinks really hard, like it kind of very similar to when we were messing around with vCluster a couple of chapters ago, and I was like, well, the virtual cluster thinks it's its own API server, but if you really wanted to, you still get to the host API. Exact same concept here. So you want to provide a way to isolate it. And so as an example, Duffy Cooley, who is field CTO over at, well, used to be Isovalent. I don't know what his title is.
I'm something at Cisco right now, but
yeah, he's something at Cisco. So he came up, with this command to show how you can break out of a container's file system. We'll look at this in a second. I'm just going to construct it here so I'll actually run on my command line, because the copy and paste out of the PDF. So what are we doing? We're going to run an image. We're going to run a pod, right? That pod is going to go ahead and pull an image, and it's going to run overrides. And we're going to say, get the host PID. So instead of using the PID, the process ID that the container thinks it's running on, we're going to get the real process ID that that the node thinks it is. And then using that, we're going to use NSEnter to join the file system from our node, mount it, and then create a file on it. That's a breakout, right? We have now gotten through our container isolation into the wider world. So let's go ahead and run it. What did I not do?
I was gonna say probably move that line.
Oh yeah,
right?
you're right.
I was wondering. Yeah, I wasn't sure if it was moved. It's hard to tell from there.
Nope. I'm just gonna say, forget it. We're gonna start over. You know what I am gonna do? I'm gonna make my life a little easier. Go into code. Nope, I just did the exact wrong thing. Try this. There we go. All right. Control N. Make my life easier. Bring you back here. All right. Once more with feeling. All right. So I am now in a container. Right? I'm root. I am root. Right? And if I look at my file system, this looks like a pretty typical file system. But the thing is, this is my node file system. This isn't my container file system. And because I'm root, I can do whatever I want to this file system. So let's go ahead and create a file, right? So let's do a touch. Oh, right. Here we go. So touch, right? So now we've got this is from a container. And let's show there's nothing up my sleeve here. Let's show some here. 256. Right. So that's my SHA sum from this file gang created. I'm just going to copy this, put it someplace else. Oops, did I not copy it? Yeah. Because I don't know how to use my keyboard. There we go. All right. So now let's go ahead and exit. All right. So now because this is kind, our node is actually a container, right? So our node, am I in the right place?
Yep. Yeah, you want
No.
to get
I'm not.
in? No, aren't you?
Yes.
Well, you're seeing it. You got to exec into it now. Yeah.
Right. Okay, interesting. Oh, I know why. Okay, I got myself confused. So this is our node, right? Client, yeah, client worker.
Should be, yes. You got a
Uh,
lingering worker 3 there.
yeah, that was probably from yesterday when I ran through this. So let's see here. Docker exec. This should work. This is directly
It should
from.
have bash in
Yeah, there
it.
we are. So there it is. So we can see the file is there. So let's do SHA-256. Let's see. Oh, I don't want to
Oh, you got,
LS.
yeah.
So 855. Yeah, 855. So that's the same SHA. So showing you there's nothing up our sleeves, I was able to break out of that container and into the root file system, and then I could cause all kinds of havoc.
It's just havoc, right, Mark? Because now, let's just say you have some nodes that you're running certain distributions. You could have cloud secrets on this now, right?
Yep.
Because they're in your kubelet or so they can get access to quite a bit.
Oh
I got
yeah.
distros that actually put the kube config on there somewhere. So
Mhm.
there could be a lot of dangerous
Why?
things.
Why? You know, when you
Yeah,
say things like that, it hurts me on the
I know,
inside.
but that's why we have to protect ourselves.
Well, right. And, I know Ian Coldwater has said this multiple times. Uh, a lot of security experts have said it. Kubernetes is not secure by default. And you can't really expect it to be secure by default either, because what is secure to you might not be the same as what's secure to me, right? Like we might sit here and joke about, oh, there's a kube config on there. Well, there's always going to be a kubelet config on there, right? Like, and the kubelet API is a hell of a lot worse to manage than the Kubernetes API. And like you said, if you're running a cloud managed, if you're running a cloud managed um, distro, you're on AWS or you're on um, GCP or whatever, the metadata is where your key is to be able to access that cloud. So once you break out of there, like that's it, right? Keys of the kingdom lost. So it's really important to lock this stuff down. Now, how you lock that down is not by doing anything to Linux so much as it is telling the API server all those extra flags we added to give it elevated provisions. We're not going to allow that to happen. And that's where Gatekeeper comes in. So we're going to get to that in a second. Before we get too deep into it, though, we talk a little bit about how to design containers. And the concept of distroless. Now, some of these, some of the things that we put in here, don't run your container as root. It was always so weird to me with Kubernetes and Docker, where like we spent 30, 40 years learning not to run services as root. And then we went to Docker, like, yeah, forget it. We're just going to run as root now. Everything's a root. You get a root, and you get a root, and you get a root. Everybody gets root. It's like, didn't we learn not to do this? Hey, Kafka, bonjour, my friend.
Kafka.
I'm pretty sure Kafka has won the best attendance award.
I believe so, yes.
But um, for some reason we got into this habit of running things as root at Docker. So don't do that. Bad developer. Only write to volumes, right? Like you should not be writing anything to your container. You know, you need to write something, create a scratch space, create an empty volume. Like that's what it's there for. Minimize binaries into your container. So this one, I tend to go counter against my fellow security experts here. Minimize does not mean to me eliminate. Right? I am not a fan of distroless. I don't think distroless is as paramount to security as distroless people like to say it is. And the reason for that is that you are making it a little harder for an attacker, but you're not making it so impossible that the potential trade-offs are worth it. Because once you've gone distroless, that means if there's something that goes wrong, you now have to use what's called, and you need to exec in. Like we like to pretend nobody needs exec, but let's be real. People want exec, even if maybe they don't need it. But sometimes when you're debugging, you're debugging a network policy or something, you got to test that from inside the container. You can't test that from the outside world. And so not having a shell in the container can be problematic. And so you get this concept called debug containers. And do we have? I don't think we actually have. Oh, we do have an example of a debug container. So as an example, and I am on page 348. So we're going to go ahead and create a dashboard container. So Kubernetes dashboard is a good example. This is the old dashboard, but it's good for our use. Is an example of a distroless container, right? The only thing in it is a Go binary, a Go compiled binary. There's no shell, there's no anything, so you can't exec in. So like we've got it up and running. I'm gonna go ahead and grab this. So let's go ahead and get the pod. And then let's try and do a exec. And it's going to fail, right? Because we don't have a shell. We don't need no stinking shell, right? So it failed, right? I'm going to put this at the top. There is no shell, right? So you can't exec into it. So if something goes wrong, if the dashboard, let's say, can't reach the API server, how do you debug them? Well, that's where debug containers come in. So going back to chapter one. When did we do Docker? Chapter 1?
Docker is 1, yes.
So we did Docker exec, Docker, to be able to attach, to be able to get into a running Docker process. This is the equivalent of that. We're going to launch a debug container that allows us to go ahead, attach ourselves. So now this is a separate process, right? So we don't see the actual process. However, we now have access to our tools. Oops, wrong one. I didn't. So like NS lookup. So if we want to debug, what DNS is happening, what trace routes happening, etc., from inside the container, we can. You notice though, we don't have access to the process ID. That's because in order to enable attaching to the process ID, you've got to share the process namespace with the debug container. That has to be turned on at pod creation. I feel like there's a security exploit there that hasn't been found yet or hasn't really been delved into yet. I don't have any proof. I don't I'm not tinfoil hat wearing here. This isn't a conspiracy channel, but I feel like that there's a exploit to be had in shared process ID or shared process namespace with a debug container. And so I feel like you're probably going to end up doing a lot of the same mitigations for that anyways. So make your life a little easier. Have those debug utilities in the container. Um, I feel like this is one of those things that in 5 years, 10 years, we're going to look back on and say, maybe it really didn't do what we thought it was going to do. 10 years ago, we said, well, of course you're supposed to rotate your password every 60 seconds, right? Of course you need a 752 character password with a number, a letter, special character, can't be repeated, no words that really exist in real life, and all sorts of crazy stuff. Well, of course you can't paste in a password from a written down password manager. Just all sorts of stuff that it is, like, did you ever watch Game of Thrones?
I have not. I mean, it embarrassingly so, because I'm a Lord of the Rings fan, right? So
Okay, so we're taking away your geek card. Sorry.
I know what.
But there's the scene where Daenerys is being integrated into the Dothraki women's culture, and the women are talking about how it is known, right? The earth revolves around the sun. It is known, stuff like that. And I feel like a lot of times in security culture, we'd be like, oh, it is known that this is the right way to do it. Is it? Like, is it?
It's not like the Mandalorian I have spoken.
Yeah, exactly. Right. So then we get into security, scanning. And this is important, right? Is you should scan containers. We scan our containers. Like, we scan our containers every night. And if there is a published patch for a vulnerability, we go ahead and rebuild. Like, that's important. There's been kind of a fervor around zero CVEs in pods. And so it's been like, well, that's something that's easy to measure, right? Like, we can measure that. And if I can measure it, almost every MBA style system, Six Sigma, the Toyota way. If I can't fix it if I can't measure it. And so CVE count is a great way for the business to measure their security. Eh, Again, if you can automate it, that's awesome. But that song, 99 bugs in Jira, 99 bugs are there. Take one down, patch it around, 172 bugs in Jira. Right? So, and in fact, the angry gooses of the Kubernetes world, Brad Giesemann, Ian Coldwater, Rory McCune, and Duffy Cooley, did a talk in 2023 about malicious security, where they're like, well, or malicious compliance, excuse me, where they're like, we're going to become compliant without actually fixing the problem. And they went through and they showed how, like, exact same code, nothing changed, but they managed to get past the scanners without any CVEs. So it's an important tool, but it's not necessarily the most important tool. So we've spent some time there. The last thing I'll say before we get back into Gatekeeper that I really like to do is, and this is less of a thing today that we have pod security standards, which I'll get into near the end of the chapter, and pod security admission. But back in the day, like, the only distro that I would say was as close to secured by default as you're going to get was OpenShift. And they have their own policy system, SCCs, but by default, you could not run as root, right? Like, a lot of the things that you would find in your standard compliance regimen were already built in. So you know what? If your container will run on OpenShift, run basically anywhere. So that I think was a great place to start with your testing. Oh, sorry, you're about to.
No, it was all good, Mark. And I don't know if anybody out there's thinking this, but probably a good segue into when we talk about runtime security, right? We're talking about all these options of like, yeah, let's make sure there's no CVEs, but what's going to stop somebody from injecting log4j, susceptible from what, 3 years ago,
Right.
into that running container, right? So your scanner says it's good, but you do a kube control CP, and now you're getting it ready for an attack.
Yep.
Going to sit there.
Yep.
Or
we dive into that next chapter with App Armor?
We will be getting into it with Kube Armor.
Yeah, Kube Armor.
Yeah.
I think that's actually next week. I think that's next chapter.
Yeah,
I finally get to
chapters.
turn the reins over to you for these labs.
But like say with exec, some people might be thinking, exec might be good for certain tools, but how do I stop them from doing other things? And that's our runtime security. And that we'll get into that. You can give exec, and let's limit it to where you can only run, I don't know, curl, right? You got to do it.
Right.
Curl's probably a bad example because that's an alert in a lot of security systems. But let's say, NSLOOKUP, something. You can limit. You can say everything else is read only, or I'm sorry, not accessible, but these 4 binaries can be run.
Yep.
You can do a lot. So yeah, there's other ways to kind of give this extra troubleshooting tools and still locking them down.
Yep.
With open source CNCF tools.
Yeah. So that's next week. That's going to be a fun. That's going to be a fun set of labs. So in order to lock down the nodes from a policy standpoint, more statically, you need something that's going to say, I am not going to allow this pod to run as root. I'm not going to run this. I'm not going to allow this pod to run as with host pit. I'm not going to allow you to do these things that you have to do in order to break out. And so that's where Gatekeeper comes back in. Now, we mentioned pod security policies. I guess it was 2021. I'm looking at the chapter when it was explained why it was going away. And pod security policies tried to integrate identity into the node security process, and it went really badly. Hey, look who we got. We got Alan.
Hey, Alan.
Welcome, my friend. And it was really hard. Like pod security policies was loosely based off of OpenShift's own SCC policy system. Same way RBAC was based off of OpenShift's API policy system. You noticing a pattern here of it first went into OpenShift and then it went into generic. Anyway, I have a lot of love for OpenShift. I don't use it much these days, but I still have a lot of love for it.
We of course, personally, Mark, never endorsed PSPs. We were always an OPA, day one.
Yeah.
When we started. And even before we knew it was being deprecated, although that was announced, well, way before it ever happened.
Yeah.
So yeah, we were always a little bit more, we were bigger fans.
Yeah.
Not bigger fans of Rego, don't get me wrong, but bigger fans of what it could do.
Oh, come on, Scott. Life is pain. Embrace Rego.
Yeah.
So, the big thing with PSP was, so there are a couple of things with PSP, why I had to go. First off, it was very Linux centric, and Windows has joined the party. Maybe not to the extent some people thought it would, but it's still part of our happy, somewhat dysfunctional family. And so PSPs didn't mesh real well with that. So that was the first problem. Second problem was you had this issue where PSPs were trying to determine if you could do things based on not just the workload that you were creating, the workload's identity, but the creator, which is really painful because you don't create pods, right? You create deployments that create replica sets that create pods. So the identity of the creator isn't you, the person who created the deployment. or your GitOps or whatever. It's the controller. That became kind of pointless, and that caused so many problems. And it's just really painful to debug and to figure out what was going on. And it was really difficult to extend. And so they deprecated it and said, we're going to go this different route. Uh, uh, we're going to have this thing called pod security admission built on pod security standards, which we'll talk about at the end. But if you need something complex, go do it with OPA or Caverno or Gatekeeper or any number of these policy engines. Now we see Alan does enjoy pain. Yes, they have, and I gave Rigo a lot of love last year, so I have no problem giving them
I got
a
no
hard
issues
time.
overall. I know I was in Sunnyvale a couple of years ago for as pretty well known Anthos fan, and I met the creator right there, and I actually did say, "What were you thinking?" And he did laugh and said, "Yeah, I know," but he had a good point. He goes, "What was I supposed to use? Python?" Well,
yeah,
Java. He's like, something had to come out.
yeah.
But yeah, I had to just kind of say, man, once you get used to it. I'll be honest though, too, to everybody, ChatGPT is really good at writing policies.
It is, except deep breaths through the nose, out through the mouth. I'm calm. I'm okay. I spent like 2 hours with ChatGPT before the last chapter trying to figure out why my policy was working in OPA command line, but not in Gatekeeper, until I finally realized that Gatekeeper uses the version 0 syntax by default. You have to turn on the version 1 syntax.
Oh,
and
wow.
ChatGPT kept telling me it didn't. And I might have cussed at it. I'm not proud. And if my new machine overlords hear me, I
I was gonna
beg you.
say, once the robotic overlords come in and they remember that, you're in trouble.
Yeah, I'm in trouble for a lot of things, to be honest. But yeah, so Alan brings up a great conversation point, or a great point here. Yes, the mutation is a great point. Now, I actually liked it. Again, pain. I enjoy pain. That's why I'm in this business. But like, we're actually going to get started here on, one of the things I liked about PSPs was that it made it so that you could have sane defaults. I am a big fan from a security standpoint of sane defaults, right? We talked about last chapter, where if I can make it so that if you don't specify what security you want, you're getting some sane defaults like non-root, right? Like no privileges being requested, dropping all privileges, right? All the other security settings. I'm going to give that to you. It might not, it won't be as, it will follow policy. And then if you need something else, we can adjust it. But I'm a huge fan of giving sane defaults. So that way you don't have to go back to the manifest and make sure the manifest sitting in Git somewhere is always correct. Because I feel like that's just an easier way to enforce that. And finally, before we get back into our labs, is with the difference between PSP and Gatekeeper or other authorizers, is that PSPs, you could define a blanket policy and say, hey, I want this to be the policy for everything, and then create exceptions for namespaces. So you can say, you know what? Nobody can run as root except kube system. right? It was easy to create those exceptions. You can't do that with Gatekeeper because it's all based on label matching, right? So in order, or it's generally done based on label matching. So if a pod matches a policy or doesn't match the policy, I guess would be the right way to do it, it's going to fail. So that means that brings up a lot of questions around how you do this with multi-tenancy. So we'll dive into that too. All right. So I've been yammering for way longer than should be socially acceptable. So let's get started. I am at the bottom of page 354. And so the first thing we're going to do is we are going to redeploy Gatekeeper. I've got a fresh cluster here. I started fresh. I always start fresh. Rated fresh on Rotten Tomatoes. So I'm just gonna fix this. Oops. Okay, that's good.
So Mark, going back on the namespace, can't you exempt on namespace in Gatekeeper? OPA, different story. OPA definitely had that limitation.
Wait a minute. Where am I? Am I still in my pod? Ha! I'm still in my pod.
Oh, I do that.
Okay.
Too, yeah.
Oh, where am I? Okay, let's try this again. Cube control.
There you go.
Weird. Okay. I'm going to do export PS1 get. Sorry, what was your question, Scott?
Let's say I know OPA you can't do a namespace, right? You gotta basically exempt it from OPA altogether. But I thought Gatekeeper had it in the constraints. You could say exempt a namespace.
You can exempt a namespace.
So I wanted to bring that up. Yeah.
Yeah, but what you used to be able to do was say, I'm going to write a policy that covers everybody as the default. And then you would add specific authorizations in for the namespace. You can't take a layered approach with Gatekeeper.
Yep.
Right. It's
I thought I'd bring that up just to make sure, because probably semantics and wording that I'm thinking, okay, wait a minute.
Right. So I've deployed Gatekeeper, and we were talking about the point of sane defaults. So the first thing I did was, we talked about last chapter creating mutations for sane defaults. So I went ahead and created a bunch of sane defaults. Here, so we created these mutations that set up kind of sane default. Privilege escalation, file system groups, you can't run as root. What groups can you run as? I'm a big fan. One of the things that OpenShift does that I really like is your pod runs with a random UID and group ID, right? Now you can't do that with Gatekeeper, but you can say, you know what? If you don't specify a UID, I'm going to set you to something, right? So vast majority of systems don't need to know what their UID is. There are a couple of exceptions, but they're pretty few and far between. So we built those, and then let's go ahead and delete all of our pods. So the important thing to understand is, we're talking about eventual consistency. If you create a policy after you launch a pod, Gatekeeper will show you whether or not it violates the policy, but won't do anything about it. Right. So if you launch a new policy, you gotta make sure to either recycle everything. You don't really want to delete it, because deleting it, you lose high availability, but you want to do something to really force those pods to get recreated. So we're going through, we're deleting all the pods. And so now we've rebuilt our system with these same defaults. So let's see what it looks like to go ahead. So we're going to create a namespace called mutations. And we're going to create a pod. Now this pod, nothing really all that crazy here. Oh, why doesn't copy and paste that? But we're just going to create this test engine X. Oops. What is going? Hi, my name is Mark. I work in computer science, and I don't know how to use a keyboard. So let's try.
No, you can use keyboard markers. It's just you can't multitask. Right?
Yeah.
You're going to talk and type. There you go.
Open Unison dash gates. Okay. All right, so I copied that. So let's go ahead, come back here. All right, so I still, what did I do? And mutations, right? Okay, so I created this deployment, and we didn't add anything special to it, right? Just standard deployment. But because we have same defaults in place, let's take a look at our security context. So our default mutations set up a default supplemental groups, default FS groups, to make sure that we were running, we're running with some same defaults. So I'm a big fan from an operations standpoint of doing it because it takes work off the developers. But this isn't a policy enforcement, right? You still need policies in place to say, okay, well, even it's great that if you don't specify anything, you'll get something that matches policy. But honestly, we want to make sure that you don't specify something you shouldn't, right? That's the carrot and the stick. The carrot is, don't do too much work and we'll take care of some of this for you. The stick is you try and do something you're not supposed to, we're going to whack you on the head. So I actually missed a step in the lab. So the first thing we need to do, I'm on page 356. The first thing we actually need to do is, let's see, there's privileges or minimal gatekeeper constraints. Oh wait, no, it's SH chapter 12. Deploy gatekeeper PSP policies. There we go. All right, so the gatekeeper team put together a set of policies to mimic what pod security policies did. So we started there. It's a good starting point. So we went ahead, deployed those into our cluster. So now we have these policies. Going back to last week, once you have your policies set up, now you need a constraint in place in order to, we have the constraint template in place. Now we need a policy to enforce that constraint template. So now I can run this command. So this is from the top of page 356. And we've gone ahead and we've created our constraints. Now, when you want to check to see if a policy is violated, the way you do that is by looking on the policy itself, the constraint, and the status section will tell you all the pods that are violating it. So this is where the big difference between OPA and Gatekeeper comes in. OPA is just an admission controller, right? If you've got something that snuck by, maybe you hadn't deployed OPA yet, you hadn't deployed a policy yet, or even you've got your admission controller configured to fail open, right? Eventual consistency, except when it comes to admission controller webhooks. OPA is not going to help you. Whereas Gatekeeper, you can monitor your constraints and see is there anything violating it that's running, right? So I create a script in here to make it a little bit easier. Let's see if we've given it enough time. So, yep, you can see here, I'm going to rerun it. So we've got a bunch of constraints being violated. The allowed users, somebody is running a privilege, an escalated privilege. We're probably going to look at that one, I think, first. Different capabilities. Now, I originally wrote this script, or the example in the book is going to be a little bit off because when I wrote this script, there were just different defaults on some of these containers. So let's go ahead and take a look at these constraint violations. So we're going to start with privilege escalation. So what we're doing here is we're getting our constraint. So this implements our constraint template. And we're going to get all the violations from the status object. And we can see that our Nginx is violating our constraint. Now, what constraint, what privilege escalation is it violating? Well, Nginx, in the year of our Lord, 2025, still wants to run on port 443 and 80 in Kubernetes. Why, Scott? Why?
I'm saying just because it runs, says Nginx in the name, so they're just going to go 8443.
But I can deploy a service on port 80. Oh God, I need a drink. Anyway, so Nginx is running on port 443 and port 80. So, we want to figure out what the heck's going on here. So let's take a look at this pod. And, oh, right. Control clear. Now, you'll notice, get space. So, we're talking about ingress Nginx. This is not the same Nginx that we deployed when we did our test mutations. That's because when we did our test mutations, we deployed the Nginx container that Open Unison uses to store all of its static HTML and JavaScript files. And we run Nginx without being on 80 and 443. I'm okay. Through the nose, out through the mouth. I'm okay. So anyhow, so let's go ahead and let's grab the name of the container that is violating it. All right, so we can see here that we are in fact dropping all capabilities, but we're adding netbind service. So that is the capability in Linux that lets me run a unprivileged system on a privileged port. For folks that have not yet taken networking 101 or Linux 101 or Unix 101, whatever 101 covers this. Any port below 1024 is considered privileged, and so you need to be root. Or on Linux, your user needs to have this netbind service capability. So this is privilege, like it is privilege, not a lot of privilege, but it is privilege, and that violates our policy. So that's why we're getting an escalation. So how do we fix this? Well, we got to give it a pass. So Scott had mentioned this before, where you can go ahead and create exceptions based on namespace inside of policies. So that's exactly what we're going to do. So we're going to update our, where am I? I'm on page 358. We're going to update our policy. And then let's see here. We're going to drop all cat or k get. Can I do that? No. Well. Okay. Dash O YAML. And then so over here, this is where we updated it and we said, okay, the policy at a policy level, we're going to say exclude namespace. And we added the ingress nginx namespace in here. Now it's going to take a hot minute for this to run. Let's see here. Did it finish running? All right. So okay. So here it is. So it's run. We can see this allow privileged escalation container. That's no longer showing that there's anybody there. And then the Kate's capabilities container is now one less. It was 5 before, now it's 4. So that's one way to attack it. Not my favorite way to do it, really, because that means changing the policy every single time, which I don't love. Right? Like it's not very dynamic. I mean, I could patch it, but like, in a multi-tenant scenario where you're onboarding tenants in an automated way, are you going to patch the policy every single time? That seems counterproductive if you need something different. And so that brings us to our next, kind of spot as we start talking about multi-tenancy. And so I've kind of diagram this one out, so I'll share it here, where ideally what we want is a globally restrictive policy that can then be tailored to your tenants if there are changes that need to be made. You could do that with PSP. You can't do that very easily with Gatekeeper because everything's based on labels. So it either matches or it doesn't. It's much more binary. So instead, what we ended up doing was we said, okay, we're going to have some system level policies, but every single namespace needs to get its own policies, right? So instead of having one policy that says everybody has to have drop all capabilities, right? We're going to say, okay, every time we onboard a namespace, we need to make sure that we need to create a policy for that namespace that says anybody in this namespace now has to have drop all capabilities. So that way, if there's an adjustment, we do it at the namespace level rather than at the global level. Can you see the problem with this approach, Scott? I want to make sure you're paying attention.
Yeah, quizzing me right on the fly when I'm trying to
exactly.
a little bit.
I see you nodding off like, oh, Mark won't shut up.
No, not that at all.
There are two problems to this approach. Can you see them?
I'd have to ask you to repeat part of that.
Okay, so instead of creating a global policy that we can then open up exception to, it's kind of like the same as the RBAC problem, right? We're enumerating everything.
Right.
So instead of creating a global policy that we create exceptions for, we're going to create policies for each individual tenant namespace. And then if those policies need to be changed, we change it at the namespace, not the global level.
Other than being a lot of work, and what do you do with new namespaces?
Right. So automation.
Yep, definitely automation, and especially that new one, right? Because you get this a lot in RBAC even, like you're alluding to, Mark, right? I want access to every namespace but 2.
Right.
Okay, well, that doesn't work.
Yeah, exactly.
You got to keep adding everyone and tracking that.
So that's the first problem.
Well, don't I get
The
credit for
second problem,
50%?
yeah, 50% is still feeling great, though.
That's true. Well, it depends what state
I
you're
mean,
in
that's not even
nowadays.
a D. You
Yeah,
just
yeah,
60 to get a D. No. So the second issue is, how do you make sure that the namespace has policies? Right? So if every namespace has its own enforcement policies, you need a policy in place to make sure that the namespace has policies.
yes. Yep. Kind of, I've almost implied that to myself, Mark, because I'm thinking, yeah, if you got to add them, how do you
Right.
know? And then you miss it, and then
So
you've got a major security hole.
exactly.
Yeah.
So that's how we did that. So the first thing we did, so I'm gonna go through, let's clear out, we're gonna clear out all our policies because we're gonna start over. And some of these are gonna say they don't exist because yeah, when I wrote this, I probably reran this chapter half a dozen times. All right, so some of the stuff was there, some of it wasn't. So the next thing we're gonna do is we're gonna create our multi-tenant policies. And I know we're at the top of the hour. I just kind of want to plow through because we're almost at the end, rather than trying to maybe do another week on this. So if you're still with us, thank you. If you had to drop, totally get it. All right, so we're going to create our multi-tenant policy. So we create our constraints. Now let's take a look at one of these constraints. There we go. Yeah. YAML. So here's our constraint, right? Here's our pod, enforcement action, right? Nothing crazy here. The point though is that this is now going to get an enforcement policy for this needs to get created for every single namespace. So that part hasn't really changed. The part that did change is looking for, well, let me see here, might be easier to do in here. In chapter 12, multi-tenant. Here we go, require PSP for namespace. So this says that you have to have a PSP for the namespace. Here we go. So this is where we're checking to see, do we have these policies in place in the namespace? Right? Because if the policies aren't there, we don't want you to be able to run any workloads. So it's a policy, you know, it's internal affairs for your cluster policy enforcement, right? So we've done that. And then, okay, we look at this in the book. Okay, so I'm on bottom of page 364. So we're going to update the config. I don't really remember why. I'm going to guess to do caching in Gatekeeper of Kubernetes objects. And then we're going to create our require PSP template. Right, so that's what we were just looking at. So that's our constraint template. And then we're going to put in a constraint enforcing a requirement that you have pod security policies. Okay, so now let's test this out. So first thing I'm going to do is I'm going to create a namespace called check new pods. And I'm going to run kube control command that will create pod, nothing super fancy. Right, we're just running a busy box image. And it failed because I don't have any of these policies in place. So Gatekeeper is saying, whoa, you don't have the policies in place. You don't get to run any workloads. So that's how you can protect yourself. And then because Gatekeeper audits, if any of these policies are, if anything's violating this policy that had already been run, you can go check the status. And you can set off alerts if you've got pods running in namespaces that don't have policy. That gives you a couple of ways you could go. So let's make it work. Let's give us the happy case. So we're going to create policies in our namespace. So we went ahead and created the policies for that pod. Now when we go to run it, there we go, hello world, right? So, policy when implemented correctly is our friend. So you spent a lot of time talking about Gatekeeper and OPA. What if you don't want to use Gatekeeper and OPA, or Caverno for that matter? So to replace, not really replace, but provide a replacement for, like it was not designed to be a one-to-one. First, the Kubernetes SIGAUTH team, was it SIGAUTH? It might have been SIG Security, wrote something called the Pod Security Standards that, and we link to it in the book, that basically says you should have profiles, and each profile should have certain sets of capabilities. And it goes through and enumerates some of the basic ones. One of the main points that it gives is that your namespace is your security boundary. Anything that you want to apply has to be done at the namespace level. So if you want to allow restricted, that's at the namespace level. That's not the pod level. And so that could be really constraining, especially in a cloud managed world where you go to mount a, we talked about in the beginning of the chapter, should not run as root. Thou shalt not run as root, right? If you go to mount a PVC, it's permissioned as root. You need it to have the same permissions as your user. So what do? You launch an init container as root, changes the permissions if needed, and then ends. That's a privileged container. It's not long-lived. It's very hard to exploit, but it is privileged. That's really hard to implement using pod security standards. So it's kind of an 80-20. A lot of clusters today will launch by default with this enabled. And so, you'll get angry messages when you try to launch stuff. Like Talos does this, where it's turned on by default, and it's in a more restrictive mode. So unless you mark the namespace as being a unrestricted namespace, you can't launch anything that says, I need port 8443 as an example, or launches a container, an init container as root, so you can repermission a mounted PVC. So that's an area where I think pod security standards probably really falls down, and where something like Caverno, OPA, Gatekeeper, etc., really comes in handy. So let's go ahead and see what this looks like. So I am on page 366. And this is our last lab, so thank you for hanging in there. So I'm going to create an unprivileged namespace, and I'm going to label it as we're going to do it restricted. All right. And now let's go ahead and run our pod. It's going to fail because we're trying to run a pod that is getting an elevated right. I'm looking at the right error. Forbidden pod violates allow privilege escalation. Yeah, that's right. So it's violating it because we're not dropping everything. We're not, we're running in a privilege escalation mode. And so pod security admission is going to get bad. Now, we didn't dive into using CEL and pod admission, pod security admission controller in this chapter. You can use pod security admissions to do some of this node security stuff. We delved into that in the last chapter and use CEL. The issue I find with that is you can't load every object type. So you can get access to the namespace and the namespace labels, which is probably where you have most of your labeling information. So maybe you could get away with it. But I just find Gatekeeper or Caverno or some of the most advanced, more advanced systems are going to be better at it.
Definitely more common, right? Just in general in the enterprise.
Yeah.
Here.
So that's our journey through node security using Gatekeeper. We used Gatekeeper here because we used Gatekeeper in the last chapter. Caverno's great, right? The other systems are great too. We started off with VM secure, different VMs and containers, showed you what a breakout was, went through all the labs. Next week, Scott, you get to take the reins again. I know I've been yammering my mouth for like 5 straight chapters.
Yeah, we started that way with me because I did 1 to 5.
Yeah.
Yeah.
Next week, Kubarmer, securing your runtime. So I don't know. Are we gonna try and get your buddies to maybe hop on?
I'm debating if we should do it with bring them in the second part, maybe make it a 2-weeker, because
there's a lot going on in this chapter. This would probably be a good 2-weeker.
If we do, for anybody who's still hanging in here or watching, recorded, it's one of the I'm gonna say inventors of it. Actually the whole team is awesome. Just got to call it out there. The Equinox team, the people that maintain even the open source for it, awesome individuals. I found some bugs here and there when I was doing some stuff in the book, not in the product, but in how we do it in kind, first of all.
Right.
Which they really did help with. They were awesome. I wanted to bring in probably Rahul from the team. I think everybody on the call would really enjoy that conversation. But I think that would get into, that could easily get into a 2-hour conversation by itself.
Yeah.
So we'll deal with it as we can think about it.
Why don't you ping me offline as to how you want to handle it? But I mean, I think this is probably a 2-show.
It is. It is. I think it'd be nice. We get our guest speaker in here then.
It's going to be a nice milestone too, because when the second book came out and I tried to do this where we did the videos of all the chapters, I didn't make it past Gatekeeper. That was the last chapter that we did. So this will be bold new world, brave new adventures to go through and streaming, getting past this chapter.
That starts our bringing in our special guests potential as well. So same bat time, same bat channel next week. And if you're in the US, enjoy your Memorial Day weekend. And we will see you next Wednesday to do Kubarmer. Thanks, everybody. Bye-bye. Thanks, everybody.